Everyone able to see the presentation?
Yes.
Okay. Okay, I can start. So this is a presentation about the machine learning user pain points from some of the interactions and interviews that we have done within internal data scientists at Intel. So that's why it has an Intel's perspective title in there. And me, Connor, Nicholas, Jason, and Carlos are all from AI products group within Intel. It's called AAPG. So the overview of the talk is simply we interviewed and interacted with a lot of internal data scientists, machine learning practitioners, and sometimes some interns within Intel. And this is like a catalog of their pain points when they were interacting with scheduling substrate like Kubernetes. And what we wanted to do with this presentation is about categorizing the user pain points into different areas and maybe give some suggestions on which areas this ML working group might have to should focus on in order to reduce the barrier of entry for people to use Kubernetes. So the user pain points is categorized into three in this presentation. One is about user experience, second one is about resource management, and the third one is about data management. So before we go into the details of those categories, the users that we interviewed and interacted with mainly fell into two categories. One of them is researchers or data scientists. They were involved in basic ML research, including changing the ways on using models itself, what models to use, and how to change the modeling techniques in order to provide better approaches for model training. The other type of users fell into the category of ML practitioners. So they had some type of business use case in mind. They take existing models and apply it to some data and come up with a service or some kind of providing some kind of a service to users. Sorry, to customers. So this is a representation of the time to solution for a typical user. In this case, it could be either data scientist or ML practitioner. So some of the work is labor intensive, some of them compute intensive, and this gives you a simplified overview of the stages for these kind of users. So for a start, they would look at the data and they would want to label the data, and then augment the data. This augmentation of data might also include some pre-processing steps. So these three steps we think are labor intensive, and then they go into the actual compute intensive or the training phases, where they actually look at what are the models that they want to train, if they want to change any details within the networking layers, they would change that in this experiment with topology stages, and then finally they would look at running these models and training using either hyperparameter tuning or some kind of iterative tuning phases, and then finally they'll look at the results and figure out whether it's useful. If it's not useful, they'll try to iterate on these models, or they would just be done with these phases, and then they'll document the results. This is a very simplistic view of iterative training. So there is model input. In this case, there is the hyperparameters or the parameters input to the models are also called as hyperparameters. In this case, there are two, I and j. They have some values u1 and v1. And in between, the user can also do some code changes to the actual modeling code itself. So they run it through model training, and then they look at the model output. The model output usually consists of something like an accuracy or an error rate, and then a loss function. So if the data scientist finds this optimal for their use case, then they move on. However, if it's not, they'll come back to the first phase and then try to make some code changes or tune or change some other hyperparameters, and then again go through the same kind of workflow till they find something that's useful for them. So this is just an example, like they'll come back and do second values, like in this case it's U2 and V2, and then they'll get output W2 and X2. The other common workflow is called hyperparameter optimization, where we just assume there are two parameters that are inputs for the model I and j, and the user wants to look at the model accuracy, loss function, and the usefulness of the model for these different kind of parameter inputs. So what they will give us is basically a matrix of input values, and they would spawn off jobs that run each of these models with different sets of parameters. At least that's what is represented here. So in this case, it's running one set of parameters. In the second case, it's running another set of parameters with different values. They each give some output, which would be in terms of accuracy and losses. And depending upon the data scientist use case, they'll figure out whether this parameter value and the model that they have used for training is useful or not. And in some cases where some of the parameter combinations might not be so useful, they would want some introspection capabilities when the job is running in order for us to look at how the model training is progressing. If they find it not so useful, they also want the ability to stop it earlier as an early stop capabilities, so that they can actually focus on the model parameter combinations that are more useful to them in order to improve productivity, for example. So the first set of user pain points fell into the user experience category. Here, a typical user would be a statistician, data analysis, or a biology grad student. They know about, for example, scikit-learn, how to use TensorFlow, they know how to code in Python, and then maybe they use some dataset management tool like pandas for data management. This slide is about barrier to entry. So we are also talking about concerns which drain productivity. So in this case, going from scikit-learn or coding in Python to running it in Kubernetes is one of the main issues, like understanding concepts related to pods, containers, what are builds, what are tags, the differences between command and entry point, the CLI and namespaces. There is also this concern of putting together a lot of information that is provided by the scheduling substrate, like job status, the pod names, the logs from the container, tying it back to the job that ran, the data that is associated with these jobs, etc., etc. So if something goes wrong, or if the user wants to debug certain runs, all these things come into play. A more concrete example of user experience is experiment trapping, which I alluded to in the last slide. It's about when I talked about iterative modeling, when the data scientists do some code changes, want to go through this workflow process where they train the model, look at the output, and figure out if it's useful, and again go back to doing the same. So it is difficult for them or cumbersome for them to decipher code changes, data related with the code changes using Docker file, they feel like it's labor intensive. And again, this comes back again about tracking logs and output. In terms of understanding what's the status of the job, they have to look at logs, tie it back to data and the task ID itself. And this kind of iterative process actually requires putting together a lot of things, and this is applicable to both hyperparameter sweeps and iterative modeling. Uh, as I mentioned earlier, they might also want to run stop certain uh, jobs that will respond in the cluster during the hyperparameter sweeps because they realized that the trial was useless. Finally, some data scientists also use visualization tools like TensorBoard in order to compare and contrast some of the runs that are being done uh, when they're using hyperparameter tuning. So in case of resource management, so this goes back to the hyperparameter tuning process where there is a set of a matrix of values for hyperparameters, and the user wants to spawn a bunch of jobs, usually in hundreds or maybe even in thousands, in order to figure out which model is useful for them. So a single user can hog all the resources in a resource constrained cluster. Um, and the requirements for like this kind of a fair distribution of resources is that these users actually come from sometimes from HPC style background. So they want to submit to the queue and forget. They expect the scheduler to act fair without their involvement. They want to know like what is the lead time or what is the wait time or expected wait time, something like an ETA for the job to run. And then they want the ability to prioritize one task over the other when required. So in terms of data management, some of the users want to assuming some of the users, if their data is stored in a stored in a data source which is not natively supported in Kubernetes, for example, they want to cache that locally and then use that data for either a distributed training purposes or simple single node model training. Along with that, not only about the replication, they also want to keep track of the data that was used for each of their runs, so that they can and both figure out which data and which parameters were used for certain run, either to discard it or to use it because it was useful for them. That comes under the experiment tracking. The other problem we have run into is around running out of local storage itself. So they want a seamless way to figure out, or the scheduler to take care of landing when they're trying to pull data from or locally cache the data from a different source into their node. They want to land on a node where there is storage space. There are also concerns about data clobbering and labels itself. This goes to role-based access control or RBAC, where they try to label data, and it's concern there is a concern that some other user within the namespace can also clobber the data. And finally, tying all of these things together, we wanted to make some suggestions of areas that the ML working group can focus on. And we have a list of we have a list of items here. It's mostly around lifting the abstractions for researchers, data scientists, and ML practitioners. Each of the pain points that we have listed directly correlates to one of the items in this list. It's regarding either templating, workflows, experiment tracking, resource scheduling, resource monitoring, and so on. These are also focused on reducing the barrier to entry for ML researchers and data scientists and practitioners for using Kubernetes. The final note about the approach is we want to also meet where the users are. some users may have already workflow, some don't understand, or some are not familiar with the concepts and use cases, or the ways to use Kubernetes. Uh, it might be better for us to meet us where they are, um, rather than imposing some sort of restrictions on them. And maybe we should also try to add values incrementally and addressing these specifying and in addressing these pain points by building from some small components and then building on top of them. So that's the end of the presentation.
This was awesome, Balaji. Thanks a lot. I mean, it's a really coherent presentation covering a lot of broad areas.
All right. Thank you. So I also want to mention that there is some ongoing work going on in each of these the items that we have talked about here. In all these list items. I mean, if time permits in later meetings, we can also present on some of the work that we are doing, but that might be at a later stage. I think now we are focusing on figuring out what are the user pain points within the cluster. For cluster usage for ML practitioners. So,
okay.
So Connor and Nicholas, do you have anything to add?
Not at the moment. Yeah, I guess everything we had went into the slides. So
yeah,
yeah. Hopefully, more people can see the recording. I guess it looks like we have a bit low attendance this week, but I'm curious to see how this matches up with other people's lists when they get to present.
Yeah, and thanks a lot for kickstarting this, because I think first person the task is really difficult for first person, because you're sort of like blazing and setting a requirement bar. Should we spend some time going over some of these specific suggestions here and sort of like highlighting what is already possible and maybe just noodling what is missing?
Yeah, sure. I mean, I'm on this slide, but
So there's a question on chat. The question is, can a link to a slide deck be shared?
Yeah, so I cannot share this slide deck, but I'll copy this somewhere else and share it with the group. Yeah.
Okay.
Yeah. So are there any other questions before we go on to what we just suggested?
I guess one comment to make is, each one of those items on the bullet list you showed, there's a whole kind of cottage industry of tools that exists kind of around those. And so a lot of this is taking stock of what exists out there and finding ways to either combine them or make them appropriate, easy on-ramps or what have you. So it's definitely not happening within a vacuum, given the amount of things happening in the ecosystem.
Yeah, the other thing I want to mention here is we want to identify the gaps, and if there are already existing tools, we don't want to reinvent those. We just want to make sure our tools are filling the gaps wherever they exist.
Okay. I have a very basic question even before we get into like more complex scenarios described here. So today as a user, I can go choose a whole bunch of machine learning frameworks. How can I get hold of frameworks that are optimized for Intel hardware? Where can I find those optimized images?
So I can speak to that. So there are some wheels that are already available. I don't think they're containerized yet, but there are availability of wheels for TensorFlow and some other frameworks as well. I don't exactly recall off the top of my head. If anybody else recalls it, they can help me out. I can send you links to them They are already optimized for MKL and takes advantage of all the intrinsics if they are available, such as AVX and FMA and all those special instructions that are available with the underlying hardware.
Okay. Would it actually, as a side question to that, does anyone feel the need for curating basically a list of tools and list of links that one should probably be knowing if they're trying to do ML on Kubernetes? Because right now, when I try to navigate this area, it's spread out everywhere. There are so many different possibilities and solutions. And for a new user, it will be a little bit daunting, uh, like not even taking into account the fact that setting up Kubernetes itself is an Herculean task just by itself. So does anyone else see value in like trying to curate maybe just a doc or a GitHub README or something of that sort that sort of links to all the tools that exist out there? And the one that most interests me is like having optimized frameworks, because that's like everybody should be using that, but finding it has been hard for me.
Yeah, I agree 100% on a list like that and the optimized frameworks. Actually, I just talked to a team yesterday who's packaging these up, and I offered to give them a big kiss because it's been such a simple, low-hanging fruit that we, it's really been frustrating that, it's kind of fallen between the gaps of several teams. And so we're addressing that, but this would be kind of a perfect place to put that.
Okay. So should it be a doc? A doc is kind of hard to discover, so I'm more favorable for a GitHub repository and a README.
I completely agree there. Essentially, it could just be like an awesome list.
Yeah.
Which to some extent, I don't know what the scope of Kubeflow is, but it seems that that in terms of the automation of all these tools and rolling them out, that would be a place for it. Or how do you see kind of the relationship between the two?
I mean, Kubeflow is definitely a candidate for us to post all this there. But the problem is there are many other solutions other than just Kubeflow, like, for example, platforms, platform.ai or H2O or Selden or I think Studio ML. Like the list just keeps growing. The ones that I can list, there's probably a zillion of them out there. So how do we stay unopinionated in terms of the application stack that people want to use, but still like give them access to all these different tools?
You probably end up with a map, like an ecosystem map, almost like CNCF, right? Where you have like 4 different ways of doing networking, you have 3 different schedulers and so on.
Yeah, I agree. Like at some point, the list will sort of start losing value because people don't know what to choose. But even at the infrastructure level, like, okay, leave the part on identifying the right set of applications to use, right? That's a hard problem with each one having its own subjective advantages and disadvantages. But just knowing how to set up Kubernetes and like what sort of plugins do you have to use, and like how do we recommend users consume namespaces and quota and
right.
recommend them partitioning their capacity. Like all that is a lot of information, right? And we have it spread across multiple different features, but there's no easy user story around that.
Right.
Or things like having optimized images, for example.
Could we put a doc like that on the website, or is it too application specific?
Yeah, so that's a good question. Maybe we can bring this up in SIG docs and like ask them if the website would be a good location for this. If not, like just having a simple repository to start with, where we can all like open patches and then just add the things that we find are going to be useful. That might be a good start just by itself. But I agree, like for discovery, having it somehow linked into the docs repo would be very helpful.
Yeah, I guess it's also been an internal problem for us where we've been trying to understand how all the tools work together and how to understand them. And then you have that big pile of kind of cognitive load versus the actual use case, which is people don't want to know, right? And yeah, so there needs to be like a bridge of that gap somehow, right?
Yeah.
And I don't remember if Balaji got to it, but the expectation is really that someone rolls in and don't care that Kubernetes is underneath. I know it's kind of a controversial statement, but it's about the code, it's about the results in the end.
Yeah, that makes sense actually. The fact Kubernetes should sort of like hide itself in the background and not come in the way of users trying to do what they want. So that'll be a win if we actually end up getting to that point. So to start with, I don't really know what's the right repository because this is more of a curative effort. And so I don't think it can be an incubator or whatever. Maybe given the new changes around SIGs and how repositories are being organized, maybe we can, like, ideally this should be part of, I should take note of that. I don't know which SIG this should actually be part of.
Maybe if you think about it's been very project oriented, right, so far. But if you think about activity, right, so if you say, labeling, right, and saying we have templates for how to do labeling, we have templates for how to do training, and so on. So it becomes the best known method of doing X, like best known method of doing TensorFlow with this problem. It might be very like a set of different things you want to use TensorFlow for, right? So if you want to use like the estimator APIs, you want to use like low-level APIs and so on. So it becomes more about the activity.
So you're saying you could have like a number of different recipes for doing a thing. Like if you want to do hyperparameter tuning, here's 3 options and how to set it up. It looked like the trend was kind of like away from the incubator repo and towards, each SIG having a separate GitHub org. Is that right? There's like Kubernetes SIG node. Can we get one made for the work group? Then we could just, make our own repo.
Okay.
Yeah, or is that an option?
That's definitely an option. I was also thinking maybe this repository might make sense to be made at like SIG Big Data or SIG apps, because you start off like trying to look top to bottom rather than bottom up. And another thing that might be helpful here is like listing a bunch of use cases or like features that we want out of the system. And like today's presentation is a good start there. So that way, like whoever wants to add features to Kubernetes, they don't like show up to very specific SIGs and then say, hey, I want to change this API here in this specific way, but rather they justify what they're trying to do at a high level and then get down to the specific SIG.
And also from a infrastructure standpoint, we might also need to add some best practices guides on how to set up the cluster for, I don't know, running ML workloads. I mean, it'll be very useful. At least it's within our group, it's kind of ad hoc, but we have learned a lot of things. And as a community, if we come together and put up a guide for setting up the cluster itself, including RBAC, how to use namespaces, how to use storages, PV and PVCs, and all the provisioners. There's a lot of things going on to bake together a cluster. So that might be very useful.
Yeah, that sounds like an excellent idea, Baji. Just capturing the existing tribal knowledge and making it easily accessible, like that sounds perfect too. Okay, so Connor or someone else, do any of you want to make a proposal for opening this repository with a specific goal, or should I take that up?
It'd be easier for you to approve it if we suggest it, right?
Okay.
Yeah, we can do that.
Okay. Yeah, I think we have a good enough rationale for doing that, and it's going to benefit everybody. So I don't expect a lot of resistance for that. Okay, sorry, I didn't mean to take up so much time on that. Balaji, should we go back to your presentation and then just spend a little bit more time on the specific points that you raised?
Sure. Connor, Nicholas, and Jason, Elson is also on the call, so they all can chime in.
Okay.
So with respect to this resource management, oh, maybe there is, okay, I'm here, so I'll start here. So with respect to resource management, this idea of fair distribution of resources comes because there are existing features that we can use like quota and priority within Kubernetes, but the users that we have are expecting something similar to HPC style environments where they want to submit to the queue and forget. In quota is actually developed using admission controllers, so it just rejects high level objects or the pods at admission time. And priority has its own drawbacks. So some of the users don't even specify priority. They either specify the same priority, for example, either high or low, then it becomes useless. So those are the problems that we see.
Okay. So when it comes to quota, the general recommendation is not to submit pods directly, but rather have controllers that then submit pods, right? Because pods can be point. So in that sense, controllers are expected to work around quota problems and maybe like resubmit new pods and like they're meant to handle that problem, right?
Right. So the other problem here is in terms of using the job API itself in Kubernetes. So some of them don't want it to restart, and there are details about how do you submit a job that doesn't restart on failure. So there are some issues around there as well. So these are some things that some of them are like just writing a best practices guide saying that this is how you would use it, and some of them we have to go around and figure out like some existing or
why is restarting a job on failure not ideal?
Well, this is something we've heard. Maybe somebody else can chime in here. And that's one of the reasons they use pods.
So I guess one comment I would make about the previous statement was if it's controller's job to handle quotas and resubmission, then it just kind of moves the problem from one area to another. And Kubeflow and stuff are coming online, but until those are in a state where they can handle basically anyone's use case, then there's still the need to submit individual jobs. So I feel like that doesn't necessarily solve the problem; it just moves it around.
Well, it moves it to a better place, right? Because some jobs contain more than one job. They might have a couple different containers involved in it. And if you're trying to figure out a priority of who gets what when, you need to have the whole scope of, okay, how many CPU consumptions will I spawn when the job starts? So that's why the controller has to be the thing that monitors that, is in track of priority and queues and whatnot, because you have to have a holistic view of every part of the job before you launch it. So you can allocate, so you can actually say, okay, I can submit this job now. Wherein the job is not the Kubernetes job, but rather a set of containers that interact in various ways.
Yeah, and just to give a bit of context for the pod stuff in Kubeflow, it's because basically there are two types of failures, right? There are failures that are retriable. Let's say your pod crashes for some reason linked to resources. You might want your job through your pod to restart and retry the TensorFlow job, right? But for example, if let's say there is a misconfiguration, a file is missing, we don't want the pods to be retried 20 times and hog a GPU for that, right? So that's why we move from using the job controller to a custom controller. So basically, we are checking the exit code. And if the exit code is within a certain range, we assume that means it's retriable. Otherwise, we just stop the job there. I guess that's mostly because GPU are so expensive that we try to optimize the time we spend with that, right?
Yeah, that makes sense. Actually, that's a that's a shortcoming of the system in that all errors are considered the same, and there's no way to differentiate between errors. And is anyone aware of filing an issue on this specific problem?
I don't think we did. I'll check that after a call.
Okay.
I mean, it is mostly around debugging and diagnosing what went wrong. So before the next restart, at least maybe a control over that.
Okay.
Yeah. Yeah, that was another point, right? The amount of sources that you potentially have to dig through, and if the submission went wrong for some reason, then you have like this sequence of steps you need to go through, like by inspecting the job, inspecting the pod, figuring out, well, it actually did get to start before you can grab the logs. Those kind of Kubernetes toolability, but I don't know if it's kind of ML specific. It's been more just like general user experience with debugging jobs, right? Because you need to go from the job to whatever pods that ended up fulfilling that job, right?
Correct. Yeah, as far as I know, our existing logging system does not annotate pod labels with specific log lines, so it can get a little tricky to go from a bunch of labels on a job to a list of log lines on some backend logging system. I think this specific feature request was raised from the Kubeflow community as well, where they wanted to annotate TensorFlow logs with specific pod labels so they can actually track it throughout the way. But we should definitely file a feature request for this, because I think this is something that Kubernetes should be doing, where our existing logging system should be providing the necessary hints to aggregate container and pod logs into higher level entities like jobs. Okay. Does anyone want to take an action item to file that issue?
Yeah, I can do it. I just asked Jeremy because he might have already been doing that. So I'll ask him, but if he didn't do, I will file an issue.
Okay, thanks for that.
So other one is about generically monitoring resource utilization. In terms of accelerators, it's not about like how many, the quantity itself. They want to introspect the memory utilization. For example, when a model doesn't fit in GPU memory, or for example even CPU memory, if it doesn't fit in there, they want to know how far they can push the system, or what how much memory is required in order for them to run those models. So maybe monitoring for getting more details about the job runs they've done so far. That maybe that's the reason why the accelerators resource utilization is there. In terms of storage, we talked about it. Like they don't want a the disk space to run out, local disk space to run out in each node.
So in terms of monitoring, there's already support for GPU metrics, right? It's just that it's not part of, say, kubectl top or the API. Is that the thing that's missing, or like what else is missing?
So I think it's like with logs, it's a way to tie back to the job and be historic, right? So you can.
Can you not do that today with Prometheus, for example?
You probably can, right? But it's probably just best known methods for how to tag everything correctly. So when you type it once, then
okay.
Yeah, so probably just usability. I don't think it's impossible to do.
Okay, because I suspect that we can cook up a Prometheus query that would do that, and maybe people can extend that.
Yeah, I've tried to use this, do that exact thing, using the GPU metrics from CoreOS's Prometheus controller that are exposed, but it was beyond my abilities, so I would appreciate some BKMs there.
Okay, yeah, I mean, maybe this is what we could do. If we have a repository, then we can actually have an issue just for this, because this is more about just documenting how to consume an existing feature rather than trying to add a new one. This should be like trivially possible. If it's not possible, then we sort of failed in trying to add this feature to Kubernetes.
That's some of the internal processes we've been doing here, where you know, there's been 3 steps to solving a problem. Like first off, and this has also been inspiring this deck, has been to collect the issue from the user themselves, add enough details around this. But the first thing we would do is to try to figure out if we can solve it with what we already have, right, and document it. Second, if it is to extend that thing that exists, and then only thirdly, that we would start like looking into new projects. Right? But I wonder if there's something that we could mirror in open source that would be something similar. Like it could be Kubeflow where you document all these kind of best known practices, but I'm not quite sure, like I said before, what the relationship is between those. If Kubeflow is an opinionated way of doing things, saying this is going to be the push button easy thing, and what's being done here in this work group is to identify there's like the landscape at large.
Yeah, I mean, there might be multiple ways to solve the same problem, and Kubeflow might be choosing the most optimal way to solve the problem. But that still doesn't preclude other users and other use cases. If you're going to, like, I mean, I don't have a problem starting anywhere. Wherever we all think is the right place to document this, then let's go with that. So Nicholas, are you suggesting that we actually have a repository in Kubeflow for this?
As long as there's one place for it, right? But as you can see here, some of this might be really simple. Right? It might not really warrant like big projects or anything like that, but just like recipes, like we said before.
Yeah.
So, Vish, in your mind, would the repo that we talked about submitting a proposal for, if people file issues there, would these be the kinds of issues that you'd expect to see?
Yes. The simplest ones are documenting what already exists. The more complex ones would be like features that are specific to machine learning. And it could be that as a community, we just give them advice on what to use if any tools already exist. If not, then we can start exploring how to extend our system to meet that specific use case. Because right now, if someone files an issue against Kubernetes saying, I want to do foo, it'll get lost because you don't know who's the right person to work on that and who can actually move it forward. So if it's focused on a specific workload, then hopefully there are enough people who are doing this as a day job that they can actually chime in and help direct that user.
I think that makes sense. To the effect that it would benefit people that may not be using a particular workflow solution. So, there are a lot of people doing ML on Kubernetes that aren't using Kubeflow. And so if we put everything in the Kubeflow org, then it might only be visible to a small segment of the users.
Yeah, I agree with that also.
Okay. Awesome. So I guess we're deciding to do it in the Kubernetes ecosystem, the core Kubernetes ecosystem. We still haven't figured out where exactly it's going to be, but I guess we'll know it through the proposal process. So Baji, going back to the other monitoring problem you mentioned, so GPU memory should already be available. So I guess there's a usability issue there.
Yeah.
Storage, aren't storage metrics already available as well?
Yeah, storage metrics are already available, but this is about just visibility for the user. And again, this would be very simply like coming up with some kind of a best practices guide to make sure that everybody understands how to expose these metrics to users. Maybe
Got it. Okay, so this falls again in the documentation category.
Yep.
Okay. You also mentioned templating. What kind of templating were you looking at?
So in this kind of iterative training process, they also do some kind of code changes where they want to just ideally they want to just be within the IDE they are using, and something else should understand that there is some sort of a code change and make sure that the Docker builds in place and then deploy it in Kubernetes cluster so that they can look at whether the job runs or not, or if they know that job is successful, they want it directly deployed in the cluster. So, and Connor and Nicholas can talk about it. They've been working on a they've been working on related area.
Okay, so is the use case one where like as an ML practitioner, I want to be able to try out my model on my workstation, make sure it works, and then push it to a cluster? Or is it one where I actually push a model to a cluster, and then I need to go and iteratively change the code that I had previously submitted, and then re-trigger another training? Is it A or B, or is it both?
It's both, I think.
Okay.
So in terms of so ultimately, so after some code changes, they would want to do this kind of a sweep. I mean, if anybody, I mean, someone else can correct me if I'm wrong, but ultimately, after doing all these code changes, they would want to do a sweep in order to figure out what parameters are useful for their training their model. So they'll at the end deploy it in the cluster, like in this model. So
okay.
So the main idea behind the templating issue there was to kind of get from source code to deployed container.
Okay.
Because a lot of the tooling that we see in the ecosystem crops up, kind of takes over at the point where it assumes you have a container built with your code in it already.
Right.
And that's not something that, some data scientists who haven't worked with scheduling environments, they may not be even familiar with the tool chain to build a container. And then, once you get kind of like this, best practice that tends to build up within a research group, how do you share those in a good way? What we see is a lot of people they may just like clone and continually modify prior projects. But improvements for one project may not get pushed back into the one that's used as a template. And so it's just a way to kind of like aggregate and codify best practices, usually focused on like a specific combination of kind of like a deployment model and a framework. So you may have like a known good way to deploy multi-node TensorFlow, for example, or just something that works within your cluster setup, so that you can ease the time from like 0 to getting something running.
I think this is a place where we should invest. I've to be honest, I've heard this from other potential users too, where containerizing their app is like a huge blocker for adoption. Like they love the fact that there's so many possibilities, but the fact that they have to move from a VM and a Jupyter-based workflow into a container-based, like auditable workflow, that barrier has been a huge problem for them. So this is an area that I've been meaning to invest some time in, which is, can we make it easy for users to move their source code? This source code is written typically against like well-known libraries, right? And like we can literally have a single file describe the dependencies. And so can we like provide tooling that would take that source code and deploy it against Kubernetes? Like Brendan's meta particle is one way to approach that. I think like Kelsey did a Go-based demo a year back, which also self-deploys. We could do something even really simple where if you can specify the specific framework that you want to use, or you don't even want to specify a framework, like you have a meta container that has all frameworks, you just literally like run a command that wraps your directory, and it knows an entry point and then just runs that. Like something really simple that makes it possible for people to try out Kubernetes and know what possibilities exist.
Yeah.
right.
I don't know if you guys have.
Okay.
Oh, sorry. Yeah, I'll just quickly. I don't know if you guys heard about Floyd Hub, but what they do, it's not on Kubernetes, but it's working with containers. And what they do is exactly what you just said. Basically, you say, I don't remember the command, but Floyd hub run -- framework equal TensorFlow or whatever else. And then they put your code into an image that already has a lot of dependencies. The issue is that the image is really heavy. I don't remember, but it's really, really heavy. But it's really easy to use. That's really cool.
Yeah, I mean, you can do some simple code introspection too, right? Like the list of, I mean, if you just say we support just Python to begin with, that's still going to capture a huge set of users. We should be able to statically introspect what libraries are being used, and then even infer what base image to use for that. So some optimization is possible, but then is this a concrete project that we should invest in as a work group?
I think as an MVP, we might want to meet users where they are. If they're already using Jupyter, I think Jupyter has an S3 backend. We could maybe add a button to Jupyter that just like, either creates a pod or something like that. Because if they're already inside Jupyter, then by default, they have all their dependencies in one place. So we can use the same container, put their code in there, and like deploy it as a TS job or some other abstraction.
That's also a great idea. If you can just have a Jupyter widget that does that. But I feel that Jupyter is just one possible IDE, and Jupyter IDE is not really that great. Maybe Jupyter Lab is better, but it's severely limiting. So for folks who are traditionally used to like regular text editors or like IDEs, then maybe that might not help them. Or put it the other way, if we can design such a tool to be modular such that it can be consumed both from within Jupyter's context as well as, like, say, run as a standalone tool, I think we could probably try to enable both.
In the other templating usefulness comes from this hyperparametric tuning, where you want to just, like, you have already a pod template. I mean, this can be already done, but we may have to just document it, how to change these parameters, something like a bash script or something for Kubernetes, maybe from Helm or maybe a custom resource which does that for you, running these hyperparameter sweeps for different sorts of containers when the pod already exists, or you've already containers your model, and you just want to run different parameters on it.
Yeah, got it. That one seems a little bit more complicated because there are many different hyperparameter algorithms, and if all you're trying to do is, like, we recommend using environment variables to design multiple different experiments, then maybe we could just start with that. And I'm getting kicked out of this room, and I think we are on the hour already. Thanks a lot, everyone, for spending time, and hopefully this is productive for all of us and help boost Kubernetes adoption in machine learning. So maybe we should revisit the rest of the stuff that we discussed, or the rest of the stuff that Balaji presented next week, or actually 2 weeks from now. Meanwhile, like, as an action item before the next meeting, let's see if we can get the repository and basic documentation going.
Sounds good.
Sounds good.
Okay. Thanks.
Thank you.
Thank you.